Okay, I've done and redone this video a couple of times because there's just so much that can be said about what we're looking at. So what we're looking at are liverworts, and the word wort means herbaceous plant in Anglo-Saxon English. And it shows up in a number of languages. So liverwort, shaped like a liver, a plant that's shaped like a liver. So Doctrine of Signatures says that therefore it has some medicinal uses for the liver, and I'm going to say probably not. Probably a little too many microbes in there. But regardless, liverworts are a branch of bryophytes, so true mosses, which do not, well, towards the true moss section would be the granite mosses, and then the sphagnum mosses, which are distinctly different sporophytes, which would be the fruiting structures. And then the leafy liverworts, and the liverworts in general, are another branch. These two are more closely related than not than, say, hornworts, and which would be another branch still, too. So, metaphorically speaking, let's say reptiles are the true mosses, and let's say flowering plants, or just vascular plants, would be more like birds, and liverworts are more like amphibians. But then you got crazy things like hornworts, which may be more like frogs than, say, or some of the really weird amphibians. There's quite a few. If you know your amphibians, there's got quite a few weird things, and hornworts are definitely, not hornworts, liverworts are definitely more like amphibians. There's some things that just do not look like what you think of as a salamander or a frog, but yet they're amphibians. So whether or not that's a collective, that might just be a collective group of somewhat related organisms. So, so all the bryophytes do not have vascular tissue. Phloem and xylem, for example. Wood is an example of collective vascular tissue made up of phloem and xylem, primarily phloem. Primarily xylem being the wood, and phloem is on the outside. So unless you're a palm tree, which they tend to be intermixed. Regardless, they're absorbing nutrients from the and water from the environment, so they're subject to pollution, and heavy metals and things like that can destroy them quite readily. So a healthy bryophyte population, mosses, or actually even liverworts and lichens, indicates the absence of pollution in general, which could be heavy metals and sulfur dioxide, et cetera, et cetera. So regardless, so when you find a lot of healthy organisms, then you'll find clean air. So the true mosses, which would be like dicranum or polystichum, or things along those lines, they tend to be more, let's say, golden green or grassy green. Liverworts tend to be more darker green, and all of them like this. The other one is a porella. The leafy one here is a porella, and this is a Connocephalum conium. And so these tend to be darker. They tend to have more oil-based chemicals in their structure. They can often be seen under the microscope, and this allows them to dehydrate and not die. So they've decided to go in that direction. Although some of them tend to be irritants, like Furlanias, tend to be irritants, which are often brown, typically, not necessarily under the microscope. You can see the green. But Furlanias are an amazing group of organisms, leafy liverworts. So the liverworts in general probably date back to Silurian, which would be the age of fishes. And so they came out of the ocean, which was probably quite fresh water at the time, not saline, and developed on mineral soils. I tend to think the hornworts are maybe more representative of what the earliest plants look like, but certainly thallous liverworts are a close second, but very, very different organisms. Well, not very different, but they're clearly different. So these plants, these liverworts, their roots go way back in time, metaphorically speaking. So what we see nowadays is the very branched tips. So certainly there's a number of genera that have abundant species, but it's not like grass or anything along those lines. It's tens rather than hundreds of species. So some of the big groups, some of the ones you'll find, they look very different and often very few species, and not necessarily terribly easy to identify. But you can picture key them pretty readily. Not so much the leafy ones, but you can picture key them. Very interesting group of plants. They look very extraterrestrial in how they present themselves. They live in environments that are very specific and difficult for other things to occupy if they were living in ecological niches. I'm thinking, dark or very minerally or very bright or very seasonal. They would be outcompeted from vascular plants for the most part, or mosses. So they're definitely living in a niche, and that's true with any living, quote unquote, living fossils. Remember that all organisms are at their pinnacle of evolution. So we're not looking at primitive organisms per se. We're looking at a product of tens of millions, if not hundreds of millions of years of surviving, which is not typically the case. So we need to respect these organisms. They probably have some interesting genetics going on, the ability to survive, probably quite polyploid in many ways, relative to some remote ancestor. But anywho's, so what we're looking at here is a typical thallous liverwort. It's fairly undifferentiated, creeping. The ends tend to die off, and then it produces. Then it grows forward, and let's see up here. Right there is a fruiting body trying to emerge. And so I should say that all the bryophytes have an alternation of generation phenomenon where you have a sporophyte that produces male and female spores. The male spores are the swimmers, generally with two flagella. I believe in liverworts, certainly mosses. And so they will, and unlike other plants, the pollen does not have any flagella. That doesn't make them animals, by the way. But the males will splash over to the females, then fertilizing will happen, and a gametophyte the gametophyte produces the sporophyte. That's how that's done. Sporophytes then produce the spores, the male and female spores. Each one of those are called a gametophyte because they produce the gametes, and then splashing occurs, and that's the sexual cycle. So it all happens outside on the forest floor, and that's tenuous. versus in the flower or on the scales of a conifer, strobili. So it's dubious. So, and then of course, not having the vascular tissue to transport nutrients is challenging too, and so forth. So, but anyway, the thallous liverwort is fairly undifferentiated. It often has a lot of rhizids that may or may not absorb stuff. Maybe capillary action brings it to the thallus, in which is probably a community in of itself. They're known for having a lot of blue-green algae in them, and which tends to fix nitrogen. So that's a pro, and I believe hornworts actually have, which are quite seasonal. When they absorb a lot of water, they'll exude a glue or goo, a proteinaceous glue, which can stick to things in their environment, and then when they dry up, it's a way of bringing them in, believe it or not, into the thallus, in which has a more of a true leaf sort of arrangement of not necessarily dermis and mesophils and things like that, but just kind of a structure. So there's a certain amount of parallel evolution. Now on the other side here, so I'm going to say is Borella. You see, they got distinct leaves. Again, there's no vascular tissue in these guys. You can see that most of that midrib there is basically supporting the leaf, and it's one cell thick. So there's the stem, and then there's the leaf coming off of it. And they'll often have a couple of sets of leaves on them, and from usually the ends, not always, so it'll produce some sporulating structures, either as a gametophyte or a sporophyte. And often these structures in leafy liverworts are like little capsules, and they'll pop, and not meant to be long-lived in any way, shape, or form. And I've been fortunate enough to see a couple of them producing spores and popping, and that's usually you need to be out in early spring in the rain to really do that. So, but it is an amazing thing. So all these guys are the liverworts are an amazing group. There's so much diversity, not a lot of species, but anyway, the leafy liverworts have a distinct main stem there, and distinct leaves that can be taken off, generally not used for identification as you would in mosses. So in a lot of these you can actually just under a microscope identify them, and it is kind of a challenge for the species. I'm going to say Frulanias actually have two sets of leaves. One of them forms a cup, and the shape of the cup tells you the species, and how the leaves connect to the stem is a characteristic of the species, and so you need to be able to look at that. And this is quite small, so there's my fingernail. So anyway, leafy liverworts, you can see they're polycarpic, or they're creeping along the ground. That's one of their characteristics, and you'll often find them on bark, rocks. They're escaping a more competitive soil environment, and they'll often be brown. So I've seen them quite commonly on all sorts of branches here in Florida. And let's see the brown right there. See if you can focus. You can see the leaves. That's a leafy liverwort crawling on the lichens. So I want to say Frulania, but I'm probably not. So I don't have a good scope at the moment. So an amazing group of organisms that even goes less noticed than does lichens, which is something to say. So anyway, there you go. So leafy liverworts versus thallous liverworts, and like that.